Alright, we're going to take a look at 5.2b. So we're going to go over more properties of rational exponents. This time we're going to be getting into division. Okay, to kind of review some of the previous properties that we looked at, right? We had product of powers and power of a power. Okay? These are kind of some of the most basic ones that we saw and we used a lot, and we still are going to continue to use them here. Okay. Product of powers says if I have two base numbers a that are the same and they both have exponents, I can combine the exponents by adding them. So for example, 5 to the 1/2 times 5 to the 3/2. Since they both have the same base of 5, we can take the exponents and add them together. So 1/2 plus 3/2 equals 4 over 2, which is the same thing as 2 over 1 or 2. So 5 squared is equal to 25, right? That one's pretty basic. Getting to the next one, power of power. So if I take some base number a that already has an exponent, and I take that whole thing and I raise it to another power, I multiply those two exponents, those two powers together. So now I get a to the m times n. So for example, we could take 3 to the power of 5/2 and take that and square it. Okay, so then we'll take 5/2 times 2, or 5/2 times 2 over 1, and then we get 3/5, which is equal to 243. Okay. Power of a product, very similar to power of a power, okay, except this time the insides don't necessarily have an exponent to them. Okay, sometimes they may, sometimes they don't. Okay, in this instance here, right, I can have a times b, and that whole thing to the m power, I can rewrite this as a to the m, b to the m. So for example, 16 times 9/2 is equal to 16 to the 1/2 power times 9 to the 1/2 power. Okay, which, looking at that, right, that's the same thing as the square root of 16 times the square root of 9, which is how we get the 4 and the 3. Okay. Negative exponent, right, whenever we have a negative exponent, okay, if it's just a regular number here, just some whole number or whatever it would be with a negative exponent, okay, remember we rewrite it. So if it starts off on top, then it goes to the bottom and the power becomes positive. If it starts off negative on the bottom, it goes to the top and becomes positive. So for example, to add another one on here, if I had 1 over 6 to the negative 5 power, right, I could rewrite that as 6 to the positive 5, and then solve if I wanted to for that, right? Zero exponent, one of the easiest ones we can see, right? Anything to the power of 0 is just equal to 1, okay? Doesn't necessarily take a lot of work to solve those ones, right? But the thing you got to be careful with those, right? Sometimes it'll have a lot of work shown and a lot of things to do, but you'll notice that power of 0 right there at the end. Okay, so make sure you are reading the questions carefully, looking for powers of 0. Okay. Now we're getting into the kind of the new stuff, okay? So this is the new things here. Quotient of powers and power of a quotient, okay? They are very similar to power of a product product of powers and power of a product. Okay. Before, right, we multiplied two numbers together that had the same base, and then we added the exponents, okay? Now we're looking at division, right? So I have two numbers that have the same base with exponents. In this case here, I'm going to subtract. Okay? Think of it like this as well to help you kind of remember. Since we multiply, we add. Okay, the opposite of multiplying, division. The opposite of addition, subtraction. Okay, so you'll do the opposites of each, right? So think of them as opposites of each other in that way. Okay. Now, looking at this, right, we get an example here, right? We have 4 to the 5/2 power divided by 4 to the 1/2 power. That's the same thing as 5 over 2 minus 1 over 2, which is equal to 4 squared, which is equal to 16. Now, going through that, okay, a little fast. The thing I want you to be very careful with is, remember, on fractions, okay, so fractions, right? 5 over 2 minus 1 over 2. We can just subtract these as they currently are because the denominators are the same. Because the denominators are the same, we can subtract. If you have different denominators, you have to find a common denominator. Okay? If you're not sure how to find that, right, you can always just take the bottom two numbers, multiply them together. Okay? So 5/2 minus 1/2 would be the same thing as 4 over 2 which is 2. Okay, when we're adding or subtracting, we keep the same denominator. The only thing that changes is the numerator. Okay, we do simplify if possible. Okay, looking at power of a quotient. Okay, power of a quotient is kind of the same thing as power of a product, right? So instead of having a multiplying problem in here, right, multiplication, we have division. Okay, we'll have a divided by b, so we have two different numbers here to the m power. That's the same thing as a to the m, b to the m, divided by b to the m. Okay. Now, another thing I want you to be very careful with is, right, we've been talking a lot about going from this form, say, to this form, right, or, from here to here. But you do need to also realize that it works both ways. You can go from a form, say, as a to the m, b to the m, and rewrite it as a over b to the m power, okay? You can rewrite things either way. There's no one way that they have to go, okay? They are reversible. Let's get into some actual examples here. So going over these. So our first one, 3 to the 4/5 divided by 3 to the 3/5, okay? This is going to be the same thing as quotient of powers, okay? This is the property that we're using, right? They have the same bases. So because they have the same bases, and I'm using division, I can rewrite this as 3 to the 4/5 minus 3/5, okay? We're subtracting the exponents. So subtracting that out, I get 3 to the 4, since they have the same denominator, we can just subtract the numerators. So 4 minus 3 is 1. We keep the same denominator, 1/5, so 3 to the 1/5. Looking at the next one, okay? Same property, same idea, right? We still have the same base numbers, so we can just subtract them as it currently is. So I get 9 to the 5/4 minus 10/8. Okay, but what you'll notice here on this one is, right, the denominators are different, so I have to find a common denominator. Our least common denominator, which is always the best choice that we could pick, right, takes a little bit more time to figure out, but if you're looking for one and you're not sure, right, you can always do 8 times 4, you can get your 32, and that is a perfectly fine common denominator. You're just going to have to simplify after. In this case, right, this one should be hopefully a little easier to see that it's just going to be 8, okay? Now to take 4 and become 8, right, I have to take 4 times 2. If I do the denominator times 2, I have to take the numerator times 2. So 5 times 2 is 10. Since this was already 8, I leave it the same for the numerator. So I have 9 to the 10/8 minus 10/8 power, which is equal to 9 to the 0 power, which anything equal to the 0 power is just 1, right? That is our 0 exponent property. All right, going into our last one here. So we've got 10 divided by 10 to the 2/5. So we still have the same bases, right? So we can still use the quotient of powers property. But let's add a 1 here, right? So when we have just a number, if it doesn't have an exponent, right, it secretly always has 1, the power of 1. Okay, because if it was the power of 0, it would just completely change the number. Okay, so rewriting this, we get 10 to the power of 1 minus 2/5, which is the same thing as 10 to the 1 over 1 minus 2 over 5 power. Okay, we find our common denominator, 10 to the 5 over 5 minus 2 over 5. Okay, 10 is equal to 3/5. So we have 10 to the 3/5 power, and we'll write that a little bit better there. Okay, hopefully these ones are a little bit easier. Okay, these are the more common ones that we'll see. But looking at the back side of our notes here, okay, we've got 3 more kind of unique problems to look at. Okay, problems 4, 5, and 6. So what's happening here, right? Looking at number 4, okay, this is going to be us using the still same property that we were using before, well, but we're actually going to use that newer one, right? So we're going to be using power of a quotient property for number 4. Because I don't have any exponents on the inside and my base numbers are different, right? They're not both matching here, okay? So what's going to happen here is we're going to give each of these are going to gain this exponent. So we rewrite this as 4 to the 5/2 power divided by 9 to the 5/2 power. Okay, and you might think that you're done there, right? It doesn't necessarily look like you can do things. Okay, but one thing you should look for, okay, when you have a very low power, okay, on the bottom number there, okay, or you have a really large number out front as your base, those are times when you should often look to see if you can take this a step farther. Okay, now reminder, okay, when we've been working in exponential form, right? So the form a to the m divided by n, right? But let's rewrite this in radical form for just a moment. So this is going to be, right, the n root of a and the entire thing to the m power. So rewriting this, we get the square root of 4 to the 5th power. Rewriting this again, okay, we get the square root of 9 to the 5th power. Okay, so this is really the same thing as 2 to the 5th over 3 to the 5th, right? Because it's just the square root of 4 is 2, the square root of 9 is 3. So 2/5, 3/5. Okay, we can then use our powers table to help us solve this. So 2 to the 5th power is the same thing as 32. 3 to the 5th is the same as 243. Since we can't simplify this any farther, that would be our answer. Okay, let's look at problem number 5. Okay, so we still have different bases here, so we can't really divide them or subtract the exponents. Okay, so we're going to give everything this -3 power. Okay, we're going to be using the power of a quotient property. So, rewriting this, I get 9 to the 1/3 times -3 over 1. Okay, because this says that we're going to multiply those together. Okay, we divide it by 6 to the 1/2 power time, 1/3 power times -3 over 1. This is the same thing as, since these cancel out, okay, they cross reduce to the 1s, but there are still a negative and a negative. Okay, so we get 9 to the -1 power over 6 to the -1. Or if you wanted to redo it, okay, we could actually multiply those out, right? I would get -3 over 1, or sorry, -3 over 3, and -3 over 3, which is really just 9 to the -1, 6 to the -1. Okay, when we have a negative, okay, it wants to flip where it goes and goes to the opposite side and become positive. So this 9 is going to go to the bottom and become a +1. The same as with the 6. It's going to go to the top now and become a +6. So we get 6 over 9, which simplifies to 2/3. Okay. Last one that we're looking at here, okay, number 6. Number 6 is kind of unique, right? This is one of those special cases I was telling you where you're going to have to kind of work backwards a little bit. Okay. So what I would do first here, okay, I'm going to take the 3/4 and just take it away from each of these. So I'm going to rewrite this as 125 times 75 over 15, and the entire thing to the 3/4 power. Okay, those two are essentially the same thing going on here between these. Okay, now I'm going to, you could, split the 15 into 5 and 3 and simplify that way. Okay, but I'm just going to combine the tops together. So, multiplying those together, we get 9,375 divided by 15 to the 3/4 power, which is equal to 625 to the 3/4 power, or the 4th root of 625 cubed. The 4th root of 625 is equal to 5. oops, that's not right. 5 cubed. Okay, so 4 through to 625 is 5. The cube remains, so 5 cubed, which is 125. Okay. All right. Since these are a little bit longer, I'm just going to go over 2 of these. These are a bit more of a kind of challenge-esque questions, but we'll go over them nonetheless. Okay. Now, what I do want you to realize is there is no right or wrong way to go about solving these. Okay. There are different ways. Okay. So, for problem number 19 here, I can either start in the middle, do the inside and work out, or kind of apply this first and then work from there. In this instance here, I'm going to actually apply the 4 first. So, we get x to the 1/2 times 4 over 1, y to the negative 2 over 1 times 4 over 1. I guess I didn't have to make that a fraction. Plus y to the 4th, x to the negative 7 over 4 times 4 over 1. Okay. Now we kind of simplify. We get x to the 4/2, y to the negative 8 over y4, x to the negative 28 over 4. Okay, rewriting this again. X squared, y negative 8, y4, x to the negative 7th power. Okay. Now, you could, in theory here, right, you can just flip where the exponents go using the zero exponent property, or we can use the, right, quotient of powers property. Okay, I'm going to use the quotient of powers property. So I get x squared, well, not minus, with a 2 minus a negative 7 times y to the negative 8 minus 4. Okay, this is the same thing as x to the 7 minus a negative 7 is 9 divided by y negative negative 8 minus 4. We get y to the 12, negative 12, which is the same thing as x to the 9th power over y to the 12th. Okay, one last one to go through because these are a little bit longer. Okay, we'll go over number 20. Okay, number 20, I apply my power first, so we get x to the 3rd power times 3 over 2, so we'll put this as 3 over 1. Y, we'll say 2 over 1 times 3 over 2 divided by x to the negative 1 times 1 over 4 times y to the negative 2 over 3 times 1 over 4. Okay. Go about simplifying. Okay, we get x to the 6 over 2, y to the, well, same, 6 over 2. Oh, sorry, this is not 6 over 2 over here, this is 9 over 2. Do something left off there. Okay. 9 over 2, 6 over 2, over x, I'll put this as 1, to the negative 1/4, and y to the negative 2 over 3 times 4, 12. Okay, remember when you're doing this, when you multiply fractions, right, multiplying fractions, we multiply straight across. Adding or subtraction, we have to find a common denominator. Okay, it's not true for multiplication where you don't have to find a common denominator for it. Okay, now that I'm here, right, we can subtract. So we have, we'll start with the x's. X to the 9 over 2 minus a negative 1/4 times y to the six halves minus 2/12. Okay, subtracting this, we get, this is the same thing as x to the 18/4 plus 1/4, right? Because minus a negative is positive. Okay. This times y, we get 6 times 2 is 12. Sorry, not 12. Oof. Tired out here. Okay. 12's on bottom. So 2 times 6, so 6 times 6 is 36 minus 2. Perfect. Okay. So looking here, right, we're going to get this is equal to x to the 19/4, y to the 4/12. Oh, oops, not 4th. Just looking back here. 36 minus 2, 34/12. Okay. So, oh, this is actually minus a negative 2. So this is actually becomes plus plus. So this is actually not 34. It should be rather 38. So, looking at this, I know I'm running out of room. X to the 19/4 times y to the 19/2 power. And that would be our final answer. Okay. I know there's kind of a lot, and some of these problems, especially here right at the end, get a bit longer. I will say there's more than one way to solve these problems, especially like problems like 19 through 22. The first 6 are primarily the ones that you'll see the most of. The last 4 are kind of some bonus challenge questions where they're just a little bit tougher, but not by that much. Okay, it just takes a little bit more thought process when you're getting into it here. Okay, just be very careful. I know I maybe made a mistake or two when I was going through it. Okay, be careful with those exponents. Okay, when you're adding or subtracting or multiplying. Okay, because sometimes you can get very lost very quickly with these kind of problems. So go back if you need to. Right, relook at what you've done. You know. But other than that, hopefully you found this video helpful. If you have any questions, right, you can leave them in the comments. Thank you.